Good afternoon, everyone. We are waiting for participants to file in. If you are in here for the webinar on confronting ethical challenges in the high-tech world, you are in the right place. We will wait for the numbers to grow just a little more, but welcome, welcome, welcome. Hello from Mexico, Rafi. I saw that in the chat. We are going to wait until it gets to about 100 or a few, if it slows down. We see people introducing themselves. We have someone from Mexico, someone from Russia. Other people are introducing themselves. Welcome. We have someone from Israel. Welcome, welcome. And we will get started. Good afternoon, everyone. I am Faye Cobb Payton. I am one of the co-chairs of the ACM's DEI committee, which is a committee that's a part of the Educational Advisory Group. Today, we are hosting this webinar called Confronting Ethical Challenges in a High-Tech World. Machine learning has tremendous potential for developing tools to improve efficiency and accuracy in decision-making in a variety of domains. However, machine learning has the potential to lead to outcomes that reinforce human biases, disproportionately impacting vulnerable populations and violating what we know as notions of privacy. Today, we have a phenomenal speaker that we are glad to be here. I will turn it over to my co-chair, Susan Reiner, who will introduce our speaker and give you the lay of the land on the chat versus the Q&A. Susan?
We're so glad that you all are here with us, and we want to encourage you to put your questions in the Q&A. We will try and get to all of them. And I want to introduce our wonderful speaker. Mehran Sahami is the James and Eleanor Cheeseborough Professor and tenured chair of the Computer Science Department at Stanford University. He's a senior fellow by courtesy at the Freeman Spogli Institute for International Studies. Prior to joining the Stanford faculty in 2007, he was a senior research scientist at Google. His research interests include computer science education, artificial intelligence, and ethics. He served as the co-chair of the ACM IEEE CS Joint Task Force on Computer Science Curricula in 2013, and co-founded both the ACM Learning at Scale Conference and the AAAI Symposium on Educational Advances in Artificial Intelligence. He's a co-author with Rob Wright and Jeremy Weinstein of the book System Error: Where Big Tech Went Wrong and How We Can Reboot. Welcome.
Thank you so much, Faye and Susan, for the generous introduction and for the opportunity to be here. It's great that we have so many people turn out for this. And what I'd like to do for about the next half hour, 40 minutes is to go through some of the topics around confronting challenges in a high-tech world. And then I also have some time for questions. So, as was mentioned, we can go through some of the questions in Q&A. So to get things started, I'm just going to share my screen with you. And then we will get going. So hopefully you can see the slides. In terms of thinking about confronting ethical challenges in a high-tech world, I want to give you a little bit of background as to where this book and some of this work actually came from. And the way that we think of this background is, as many of you might be familiar, in the last 15 years or so, computer science enrollments in the United States and in certain parts of the world have grown tremendously. But what we've also seen in the last 10 years or so is the optimism that surrounded technology, where people would think technology was going to solve a bunch of problems for us. And if we just had more entrepreneurship and we had more technology, we could tackle the big problems in front of us. Sort of a turning around and a sense of a real tech pessimism, where technology was creating lots of problems for us. It was exacerbating inequalities. It was creating a platform for misinformation and disinformation that was affecting our elections. And so there was a real change in feeling around what technology could do. And our sense at Stanford was that there was really a middle ground here, that we didn't have the feeling that technology was going to solve all of our problems. We were not eternal optimists. And at the same time, we didn't think it was all doom and gloom. We need to think about there is some middle route there that is what we think is closer to the truth. And what we need to do is to get students to understand some of the nuances that are involved in thinking about these issues, and more broadly, thinking about having the citizenry, not only of the United States, but people from all parts of the world, thinking more critically about these issues and how we address them. So this was our team. The people from left to right are Rob Reich, one of the co-authors of the book. Next to him is Hillary Cohen, who is one of our first research assistants when we started this effort. Next to her is Jeremy Weinstein, and I'm sort of on the far right. And there was a lot of things going on in the press at the time, too. We'll talk about some of those as we go along. But one of the main takeaways that we want people to understand is that technology, like many other industries, produces a set of externalities. In the language of economists, we would think of these as negative externalities, much in the same way that a factory, for example, would produce pollution. And the idea here is that there are potential benefits we can get from technology, but coming part and parcel with many of those advances are these externalities that society, in some sense, has to absorb the consequences of. And that lends itself to particular sorts of value trade-offs that we need to be more explicit about and we need to understand. Because oftentimes we think that the solution to technological problems is more technology, and that's not always the case. And it's important to bring different points of view and different lenses of understanding to think about that topic. So one of the things that we try to instill in our students is this notion of thinking of computer science in some sense as the new physicists. If you think about the physicists in the middle of the 20th century and the Manhattan Project that gave us nuclear weapons, many of the physicists at the time actually realized the broader impacts of their work, and several of them actually, even ones involved in the Manhattan Project, became peace activists because they understood sort of the larger social consequences of the technology that they developed. And what we've seen now is that many people have actually likened computer scientists of the early 21st century, where we are now, to the physicists of the mid-20th century. And so we get works like Cathy O'Neill's wonderful Weapons of Math Destruction, which is a great book. I would highly recommend it. But you can see in terms of the parallel construction in the title of that book with Weapons of Mass Destruction, the parallels that are being drawn between the work we potentially do as computer scientists and the potential impacts that they can have on the world. And so, as I mentioned before, in both cases, both in the development of nuclear weapons and in the development of other technologies in computing, more technology does not provide a complete solution to the problem. And for historical context, let me give you the example with the Manhattan Project. When nuclear weapons were developed, an arms race ensued in the 50s, 60s, and 70s. What we really got was the development of more technology, of more weapons, of bigger bombs, of multiple warhead reentry vehicles, all kinds of technology. And the technology by itself was just leading to an escalation that the ultimate outcome of that situation would be the use of weapons, which is the outcome we don't want. What it actually took was an understanding of people from other domains, primarily economics and game theory, to come up and understand a theory of mutually assured destruction that for the last 70 years or so has actually given us peace in a nuclear age. It wasn't more technology that led us to think about a potential stable point in that problem. It actually was a different sort of thinking that came from different disciplines. And it's that sort of same humility we need to think about in the sense of computer science, trying to address the problems that it is creating in the world. Is we alone will not be the ones to solve the problems that we're generating. What we need to understand is the interplay between technology, between public policy and societal impact, and ultimately what are the values that we care about instilling or promoting, and how do we sort of hone the technology to best align with the value trade-offs that are at hand. Let me give you a simple example. And we can talk about autonomous vehicles for just a moment because they've gotten lots of attention. And the reason why I want to bring up this example is not because of the traditional just notion of thinking about, oh, here's a new technology, but understanding this as a case study for thinking about the development of technology and economic and market consequences as a result, and what that actually means for us as to whether or not the market alone can solve the problem. Because that's another thing we often hear is, well, regulators or government should get out of the way. These problems will be solved by the marketplace. Let's see if that's actually the case by looking at this fairly prominent technology that is playing a greater role in our lives. So if we look at autonomous vehicles, right, these are some pictures of a car named Junior that took part in the DARPA Urban Grand Challenge a few years back. And at the time, Sebastian Thrun, who was the professor at Stanford who was leading this project, said it's a no-brainer that 50 to 60 years from now, cars will drive themselves. This was back in 2011. And at the time that he made this assertion, there was actually some people who believed that this time frame was far too aggressive, that it was going to take longer than 50 to 60 years to actually get autonomous vehicles out on the road. What we found is that the rate of technological progress was much faster than many people expected. By the next year, Nevada had actually become the first state in the United States to issue an autonomous license for a driverless car, because you see here the interplay between technology and public policy already coming up. The developments of certain technologies necessitate the involvement of government to be able to update the rules that govern how people are interacting with these technologies, in this case, licensing. And just a few years later, this was a picture I actually took on El Camino Real, which is the road that runs through Palo Alto and its neighboring town, Mountain View, which is where I'm located, of one of Google's self-driving cars in August of 2015. Right, so the amount of time it actually took for autonomous vehicles to actually reach the road was far less than 50 to 60 years. We had far less time to think about things like regulation and value trade-offs and how people would interact with these kinds of technologies than we might have actually expected, which behooves us to think about these technologies before they're developed, while they're being developed, and not think we have time always to deal with consequences later. Now, there's often some obvious benefits that are touted about autonomous vehicles. For example, it's been said that in the United States alone, you could save about 300,000 lives per decade, so about 30,000 lives per year, because there's about 50,000 fatalities a year in the United States in driving accidents. And if you could save some portion of them, that is a huge number of lives saved. That's even more true in other parts of the world where driving is even more dangerous. So if we could get autonomous vehicles on the road, human beings are pretty bad drivers. Those autonomous vehicles might actually save lots of lives. It turns out we're pretty bad drivers if you actually look at the statistics. The National Highway Traffic Safety Administration estimates that about 94% of accidents in the US are caused by human error. When I first saw that statistic, I thought it was high, and then I thought, what else causes accidents besides human error? Because we don't have autonomous vehicles broadly on the road. The rest of those accidents are actually things like mechanical failures in cars. But what you can actually see is that we're pretty bad drivers as human beings. So potentially we could do a lot better if we had these autonomous vehicles. Now, what this has done in the last few years is kind of create this whole cottage industry around thinking about problems like the trolley problem and how we think about instrumenting autonomous vehicles. And I don't want to belabor that point. I do want to bring it up for one reason, not to sort of have the whole debate around the philosophical discussion, but to think about what are economic consequences, what it means in terms of a regulatory landscape, which is oftentimes not how it's thought about. What we have is a moral challenge here. The moral challenge we have is, let's just say, how should this autonomous vehicle be programmed? Should it try to maximize driver welfare? So should it try to protect the person driving the car or the people inside the car, or global welfare? Should it try to minimize casualties on the road? And so if we think about having to program a car like this a priori, it means we have to actually confront these kind of dilemmas when we are developing the technology. And as I mentioned, this kind of resuscitated new life into a 50-year-old problem called, actually more than 50 years old at this point, the trolley problem, which has been looked at ad nauseum in the philosophy community. If you haven't seen the trolley problem before, I will just show you kind of the autonomous vehicle version of it, just so we can see what the implication of this is. Simple version of it is there's a person in an autonomous vehicle that's driving down the road. It's a very stylized example. There happen to be 5 people crossing the road. The car realizes like its braking system has gone out and so it can't stop. And it has one of two choices when you fully stylize the problem. It can either continue to move forward, running into the 5 people in the intersection and killing them, but saving the driver, or it can realize it can actually save more life by just swerving the car off the road, killing the driver, but saving the 5 people on the road. Now, this has been, it makes for a great, if you haven't seen it before, it's a fun problem to, debate late at night, especially with students. Many people have seen this problem now. Why am I telling you about it? The reason why I'm telling you about it is that this is an example of where markets break down to solve the problem we care about. So this problem was actually studied a few years back, where people looked at the notion of what do consumers actually want in a domain like this. So Bonifant and colleagues a few years back basically went and surveyed a bunch of people and said, do you want a utilitarian autonomous vehicle? That's what the AV is here. Do you want it to try to minimize casualties on the road? So if we think about preserving human life as much as possible, that's kind of the utilitarian solution from a philosophical standpoint, if you believe in utilitarianism. And this little graph shows you, 0 says protect the driver at all costs, 100 is minimize casualties on the road. The vast majority of people said it should try to minimize casualties on the road, which if you actually just pull people, that's the outcome you often get. Let's try to save life as much as possible. But then you dig a little deeper, and what you find is when people were asked what would they prefer in terms of the programming of an autonomous vehicle for the vehicle they buy themselves, most people said we'd actually prefer to ride in autonomous vehicles that protect their passengers at all costs. And in fact, they would disapprove of enforcing utilitarian regulations and being less willing to buy an AV that was trying to maximize human life or minimize casualties on the road. This, in the language of economists, would be what we refer to as a market breakdown. Basically, there's a societal outcome we would like to have, which is to minimize casualties on the road. If we just let free market forces basically dictate what happens in this problem, free market would say that the companies will produce the vehicles that people are most likely to buy, which are the ones that actually protect the passenger at all costs. And so the result we get from a free market solution is a different result than we might choose as the societal solution. So when you hear sometimes say, what should happen is government should just get out of the way, that's kind of a cop-out to really dealing with the difficult issues, because there are certainly cases, this is just one of them, where not having any regulation involved will not get us the societal outcomes we want. So it brings up this broader question of then how do we think about what are the outcomes we want? How do we potentially get there? And that's the place where the last few years, the work I've been doing with colleagues Rob Reich and Jeremy Weinstein has basically looked at exactly this point, is the interplay between technology, between policy, and between philosophy to think about what are the value trade-offs. So we teach a class called Ethics, Public Policy, and Technological Change. As you can sort of see, each one of us got to pick one of the terms in the title for that class, so it represents all the different viewpoints. It's actually cross-listed in a bunch of areas, so it's not just a computer science class, it also is a class in the philosophy department and the political science department. And this was the background for, after teaching this class for several years, how this book System Error that we wrote together, where big tech went wrong and how we can reboot, that was the genesis for this book. And the real point is, why did we write the book? We did want to, as I mentioned, in the start, point out some of the negative societal consequences of technology, trying to take a balanced view with the fact that there's also lots of benefits, but to really unpack systematic drivers of how we got here. What you often see played up in the popular press is, let's get the CEOs of a bunch of tech companies out in front of Congress or in front of the EU Parliament or whatever the case may be, and ask them a bunch of questions about why their companies are doing the things they're doing. Oftentimes what those questioning actually reveals is that many of the policymakers are pretty ill-informed about technology or fairly naive. They are getting much better, I would say, in the last few years. I wouldn't use, congressional hearings from a few years back as the guiding principle. If you look at what they're doing now, they're taking it more seriously. But what we try to unpack is it's not about individuals. It's not about just let's bring these CEOs out because they're bad people. That's not the argument we're making. The argument we're making is that almost no matter who you put in those positions, you would get the same outcome because there are systematic forces that cause the particular externalities that we're talking about. And we'll unpack those in just a second. And to offer some pragmatic ideas to harness the benefits of technology while trying to mitigate some of the harms. So if we think about the drivers of these externalities, there's three. We lay out. The first is what we refer to as the optimization mindset. That's the fact that in computing, oftentimes what we seek to do in solving problems is to optimize, right? If you think about algorithm development, for example, we think about things like runtime efficiency and memory efficiency. We try to optimize those things. When we think about other broader problems, oftentimes there's some objective function we care about, say in machine learning, oftentimes we want to minimize error, and then we go through some optimization procedure. And that mindset lends itself to thinking about life as an optimization problem, right? If you think about people who do life hacks, how do I save time? How do I do the kinds of things that make my life more optimal? That's the kind of mindset we're in. And when we think about problems in ethics, they are not problems of optimization. They are problems of trade-offs. There are better and worse solutions. There is not necessarily an optimal solution. We'll talk more about that, but to give you a simple example of the problems with optimization, if you consider, let's say, a company like Meta, formerly known as Facebook, their stated mission is to connect the world. What does it mean to connect the world, right? If you want to think about that from the standpoint of what computer scientists do in a business, they say, let's define a bunch of metrics and optimize those metrics. So we try to optimize things like the amount of time people spend on the platform, the number of pieces of content that they click on, how many likes they give to something, or how much interactivity they have. Okay, that's might seem like a fine measure. Those are now become measures that the business wants to optimize. And the problem is that those things can oftentimes be poor proxies for the notion of actually connecting the world. Because it turns out people tend to click on content that they find infuriating, that they find titillating, that is content that actually may not be something that connects people, but actually divides them. And so the things that we measure may not actually be the things that we truly care about. But when we just optimize the things that we measure, we push ourselves in a direction that actually gets us away from the actual outcomes we'd like to see. This now gets combined with a notion of obsession with scale, right? One of the things we like to do as computer scientists, we like to scale everything. We like to scale our technologies. We like to scale our server farms. You also see it in the business world where venture capital wants to see return on investment. And so when they fund companies, they want to see those companies scale quickly to dominate markets, to be the leaders. Because if you look at sort of the distribution of returns, the leader in any one market actually tends to have a disproportionately higher market capitalization than the second or third, certainly more than the, going down the list. And it's disproportional. It tends to oftentimes be an exponential drop off rather than sort of an even distribution. So there is a push in the marketplace for having scale in business, which means go optimize those metrics even more. And then that gets combined, if you look from a public policy standpoint, with the deliberate indifference from politicians. So if we look at the regulatory landscape, for example, to focus on the United States for a moment, you find that back in the mid-1990s, if you remember, Al Gore invented the internet, right? That we all thought that was kind of funny as computer scientists. Why did people even, think that, or why did Al Gore claim it? Because what happened at the time actually was a lot of the regulation around commercial activity on the internet got rolled back. So it created a regulatory landscape, what we like to think of as a regulatory oasis, that indemnified a lot of technology platforms through things like the Communications Decency Act from the content that was actually placed on their platform. It allowed for these platforms to grow with little regulation, which in some sense in the mid-1990s probably was actually the right regulatory pathway to take because it allowed for the internet to flower. But it's now 30 years later and we live in that same regime, even though the technological landscape is very different. And it behooves us to think about, if this is the landscape we live in and we don't have any controls, are we actually getting the outcomes that we care about? And so then we get into actually looking at some of the different issues and outcomes that we get. One thing that's been written about extensively in the computer science literature, as well as other kinds of literature, like in sociology and the law, is algorithmic bias and fairness. The notion that more and more algorithms are making significant decisions in our lives and that they have been shown to have signs of bias and have signs of fairness. So how do we think about these kinds of things? What does it mean in the broader picture? And again, we're not Luddites here. We don't believe the solution is to say, don't use technology to make high stakes decisions. What we say is you need to understand the promise and the peril, right? As I mentioned, algorithms are widely used, across some of the most important domains in our life, things like credit scoring, resume screening for employment, who gets access to healthcare, the criminal justice system, who gets access to bail or who's incarcerated while they're awaiting trial. And the promise is to improve accuracy and efficiency over humans, right? We are slow, we are error prone, we have randomness sometimes in our decisions. And so if we can do better than human beings, maybe we can actually make some progress on a societal basis. The downsides, as you probably all well know, are the things like the fact that if there is bias in the data, that bias gets encoded in the decisions of the algorithm. There's a threat to fairness if different groups are being treated differently. And there's also threats to things like our privacy as more and more information is being used in these algorithms to make decisions. It also brings up what we kind of think of in classic legal literature of what sort of transparency is there, or if someone wants to challenge the decision of an algorithm, what sort of due process is allowed? Because if you just ask an algorithm to make the same decision with the same data, it will produce the same decision again, which doesn't actually give you due process to be able to revisit and understand other mitigating factors. So I like to think of algorithms as a mirror. Basically, they are a reflection of what we choose in our society, but that means we have to make choices. We have to formalize what needs to be optimized in an algorithm, which means we have to make value trade-offs. And so if we want to think about algorithms for decision making and we care about fairness, we have to be precise about what fairness is, which actually turns out to be a pretty difficult problem. Most people sort of think of fairness like, oh, I can kind of evaluate something's fair when I see it. That's not what would work for an algorithm, right? We need to have a mathematical definition that the algorithm can try to optimize. And this has been an industry in the computer science research community for the last few years, is looking at different definitions of fairness and trying to understand what it is that would be, for example, the objective function that algorithms should try to maximize. But what we need to understand is it's not just about objective functions. It's not just a mathematical problem. We need to think about the broader context of transparency. Do people have a right to know when an algorithm is being used to make a decision about them? Do they have a right to know what sort of data is being collected about them and what the context is? How can they challenge those decisions if there is any sort of due process? Is there accountability? These are broader questions that are not technological questions, but are critical to answer when we think about a decision-making process being put in place, to think about who has responsibility for that process and what sort of safeguards are in place. Now, this notion of what is fair, I'm not going to belabor, but it turns out this notion is, not something that we just think about mathematically, which is oftentimes how you see in computer science, but there's a rich literature, for example, in the legal community, and a lot of concepts that exists there. For example, the notion of protected characteristics, which are characteristics you may or may not be able to use in particular contexts to make decisions. So it turns out some characteristics like someone's race, gender, or age are protected in the context of, say, employment decisions. You can't choose one person over another person for a job based on their gender, for example. But in other contexts like medicine, those attributes may not be protected. We may actually want to prescribe people different sorts of treatments based on their gender because there's different physiology, or based on their age, even though age is something that would be discriminatory in a legal context, in an employment context. And so what we need to think about is kind of this broader notion of what's referred to as disparate impact. It doesn't matter if you don't have the intent to discriminate. And one of the things we often talk about is in these kind of ethical issues, oftentimes people think, well, there's just bad people making decisions, right? We saw things like the Theranos scandal, and it was just people who made bad decisions. And if we can get rid of that, bad decision-making problem, we solve all the problems. And what we say is it's not about good or bad people. It is about the impact of what you're doing. There's lots of well-intentioned people in the world who build technology whose impact actually is negative. And that's where the notion of disparate impact comes in. What the law says, it doesn't matter what your intent is. What matters in these particular contexts is, are different people being treated differently, where different people is defined by these particular protected characteristics, like different races or different genders or different ages. All that matters is what impacts the people, not your intent. And that's the message we try to get to our students, for example, and other folks that we interact with, is it doesn't matter if you are well-intentioned. That is not sufficient in terms of the outcomes of the decision-making process. So when we think about this notion of fairness and we think about algorithms, one of the things that also comes up is, what is the standard that we're trying to improve on? And when we think about that, as we can consider, so how fair are human beings? If human beings are making these judgments right now, we're not going to get to a 100% in terms of perfect decision-making with algorithms, but can we do better than the human? And so here's a little study that was done by Danziger and colleagues. Actually, it's about a decade old. And one of the things I will mention is that there have been follow-on studies since then that have shown the effects are not as large as they measured in their original study. So please take these results with a grain of salt. They have been mitigated over time. But I want to just highlight the initial study to show you the disparities in human decision-making. Right. And so what they looked at was they looked at what is the chance if in the criminal justice system, they look at judges. They say, what is the chance that you will get a favorable outcome from a judge based on the time of day? So essentially the x-axis here, the x-axis is ordinal position of cases throughout the day. So it's not just time on an absolute scale, but sort of where cases came during the day, all in sorted order based on time. And then the y-axis is the proportion of favorable decisions that were made by judges for that position of case. And so you can see at the beginning of the day, there's a much higher chance of getting a favorable outcome, and that drops off at this midpoint over here where there's this little dashed line, and then it jumps up again. It's like, well, what happened there? That was lunch. So what happened was there at the beginning of the day, you get more chance of a favorable decision until over time the judges get hungry and they get kind of grumpy and you don't get as favorable outcomes. And then after they eat, they're sort of happy again. And same kind of effect happens. There's a drop and then there's an afternoon break where potentially they get a chance to refresh, get some more food or whatever the case may be. And again, outcomes become favorable and again drop off. Right, an algorithm wouldn't have this effect. An algorithm would be, as long as it's not updated during the day, would have a straight line across during the day. So we might say that has some potential advantages for us. But when we dig into the algorithms, we can actually try to understand, do they have other sorts of biases? And clearly they do. There's this algorithm that's been studied quite a bit now called the COMPAS algorithm. I show it to you more out of a sense of these days, when you talk about algorithmic bias, it's almost required now that someone mentions the COMPAS algorithm. So I'll be the person who mentions it. It's a black box model that was eventually originally developed by a company called Northpoint. They've since changed their name to assess risk of recidivism. And so if you get nothing else out of this talk, it's that recidivism means the chance that someone will commit a crime again in the future. And so what this model is trying to do is based on a bunch of factors. There's actually a questionnaire with 137 questions that are asked to defendants. What it tries to assess is what's their likelihood to commit a crime again in the future. So tries to provide a risk assessment to the judge should the judge release them pending their trial, release them on bail or not. And it predicts the score of recidivism based on features of the individual. It turns out even of the 137 questions, there's only about 6 that have a high coefficient in some sense or high impact on the decision that's made by the algorithm. And race, importantly, is not one of the input features to the model. So you might say race is a protected characteristic in a context like this, should not be input to the model, and it's not. But let's see what happens. So here's a contingency table. We can actually ask take some real data of people who were released and say, would they have been labeled high risk or low risk by the algorithm? Those are the rows. And did they actually recidivate? Did they create a crime or did they commit a crime prior to their trial or not? So you can measure that data in the real world. ProPublica did this with some data from Broward County, Florida in the United States. And what they found was the score from the system was correctly predicted recidivism only about 61% of the time. Remember, this is basically a binary classification problem. Actually, they had low, medium, and high risk, but 61% is not great on an absolute basis. And if you looked at its decision-making for white defendants versus Black defendants, it actually was correct slightly more often for Black defendants. And so you might say, well, these numbers are pretty close, maybe not a lot of bias here, until you dig more deeply. And this is really the point of the analysis, is when you want to look at the outcomes of algorithms, you need to do a more significant analysis to understand what they're doing. What ProPublica actually found, they're a database journalistic outfit that actually disbanded, as my understanding, a few years ago. But the folks involved in the study are now doing other kinds of journalistic projects. The way the misclassifications were made showed a high degree of bias, right? So Black defendants who did not recidivate were labeled high risk 45% of the time by the algorithm. For white defendants who did not recidivate, they were labeled high risk only 23% of the time, so nearly half. Which means if someone was not going to commit a crime in the future, they were much more likely to be labeled as high risk and potentially detained as a result by the judge if they were a Black defendant. And if you look at sort of the opposite effect of the people who would have recidivated, how many would have been labeled low risk? For Black defendants, that was 28%. For white defendants, it was nearly double that, 48%. So there is a clear indication of bias based on race in this algorithm, even though race was not one of the input features to the model. So just saying not putting in race as a feature sort of inoculates us from potential racial discrimination is absolutely the wrong thing to assume. And that's why we need to audit and study algorithms like this before we just release them into the world to make these kind of decisions. So the computer scientists have come along, done a lot of analysis on this problem and said, if you try to mathematically define fairness, there's this sort of famous tutorial by Arvind Narayanan that defines, 21 different notions of fairness, which are all plausible, mathematically different. And it turns out that, we could ask the question, why can't we just optimize them all? It turns out many of those definitions are mathematically incompatible, which means trying to optimize one or increase it by necessity potentially lowers other ones. And so we have to make decisions. And one of the things we also need to consider is there's proxy characteristics. So you could say, for example, in the case of the COMPAS algorithm, it doesn't have race as a feature in the model. Well, it turns out your zip code is highly correlated with your race in places like the United States because of the history that exists in the country. And this is actually true in many places, right, that have geographic codes in terms of residences. And race is a protected characteristic. Zip code is not, but it is highly correlated. And so it's what we kind of refer to as a proxy attribute. It's an attribute that encodes a lot of knowledge about some other attribute, but is not necessarily in itself protected. And of course, part of the big driver of this is that there's historical bias and disproportionality in the data. Human beings have made biased decisions in the past that has generated data, which is now used to train algorithms and who will potentially continue to make biased decisions. Now we can just understand it a little bit because we couldn't cut people's heads open to understand the bias in their decision-making process, but we can study algorithms so it provides an opportunity for us to look at this in more detail. That's just one of the topics. There are some other ones. I'll spend a little bit of time on data maximization and privacy, the notion that, in the tech world, people try to collect as much data as possible, kind of this notion of we don't know if it'll be useful, so let's just get all the data. And so some people just say, well, privacy is kind of an antiquated concept. Why do we even worry about it? And the way I think about it is, we think about data privacy involving competing interests. And one way to simply think about the value of your privacy is to imagine if you had none, if everything you said, everything you did, your location all the time was constantly recorded and was made available online to anyone who wanted to see it, the question is, would that change your decision-making process? Would that change your behavior? If it would, then you begin to understand the true value of privacy. Privacy is critical for our autonomy as human beings. It is critical for us to allow us to live lives, to make the decisions that we want to make without a constant threat of surveillance. And so when we think about the values involved of privacy, it's not just keeping secrets, but is actually being able to make decisions in our lives that we feel are not constrained by the fact that everyone knows everything we're constantly doing. There's also value to make data available, though. When I talk to friends who do things like computational biology, one of the things they often talk about is their main limiting factor is access to data, and that they could potentially build systems that would get us better healthcare outcomes or would make better recommendations for what sort of treatments we should give for particular diseases or particular pathologies if we had more data for building those models. But we have regulations around health data. We don't necessarily have regulations around other kinds of data. There's also the use of data on, private goods like personalized advertising, which we're probably all familiar with, so I won't belabor that. But really, part of the issue here is trying to understand how we value this particular notion of privacy. What does it mean for a self-determination? What does it mean for a freedom of speech or activity or avoiding things like discrimination? And so there's lots of regulations there. It's so important that rather than just giving them 3-letter acronyms, we give them 4- and 5-letter acronyms, like FERPA protects educational records, HIPAA protects medical records, hopefully many of us are familiar with the General Data Protection Regulation from the European Union that is elevating privacy as a human right and uses that as a framework to guarantee privacy. And then there's the basic notion of preventing access from adversaries. Now, one of the things we often do when we think about data is we think about, well, let's anonymize it. So, data might be like rows in a database. One thing I might want to do is just say, drop any personally identifying features. So let's say I'm in this data set, there's someone else, Claire Smith, just made up from Google. Why don't we drop our name and social security number because that's personally identifying information? That seems reasonable. And then you think, well, okay, well, Maron also just told me about these protected characteristics, things like age and gender. So why don't I drop them from the data as well, just to make sure that I'm, not putting in any protected characteristics. So gender goes away, the year that someone was born and their date of birth will also eliminate from the data. So you begin to look at this and you might say, this looks pretty anonymous. And this might be, for example, medical records, like whether or not, the people in this database have a particular condition or not. And we want to measure things like, are there particular regions of the country or particular occupations that lend themselves to particular kinds of medical conditions? And so we might say, well, how well does this work, right? We just got rid of all this personally identifying information. This looks pretty anonymous. So what I'm going to do is take that first row that represented me and just drop it as plain text into a search engine, see what I get. And hey, guess what? I'm the first result. So I'm one web query away from being de-anonymized, right? It doesn't work particularly well. And you might say, well, Maron, there's some stuff on the web. Maybe it's easier to identify you. Well, let's look at this in the more general case. Okay, so here's an actual case from Massachusetts hospital visits from a few years back. 135,000 medical records were made available, anonymized medical records, right? So personally identifying information was supposed to be eliminated from those records. And William Weld, who was the governor of Massachusetts at the time, assured the public that their privacy had been protected because identifiers were deleted, okay? So enter LaTanya Sweeney, who's now a professor at Harvard, was then an enterprising graduate student at MIT. She decides to investigate this a little bit. She knew that Weld lived in Cambridge, Massachusetts, because she was at MIT at the time. She knew that, that's where his general location was. And so for $20, she goes and buys a public record, which is the Cambridge voter list, right? This public information. So the $20 is basically just to get sort of the version of it from public record. And it includes people's names, their addresses, including their zip code, their birth dates, and their genders for about 55,000 voters in the city. And so what she does then is very clever. She joins that data with the GIC data, the medical records, and she's able to perfectly de-anonymize Bill Weld in that data. How does she do it? There's only 6 people in the data in Cambridge that shared Weld's birth date, and only 3 of those 6 were men, and only 1 lived in his zip code. So he was perfectly identified. And then the thing I love about the story is, to make a point, Sweeney actually sends Weld's office his medical records. So he can be aware of the fact that the anonymization did not actually work. She then does follow-on work to show, some people might say, but Bill Weld, again, public figure. This is one of those things that, maybe people know a lot about him. She then goes and does a follow-on study that says 87%, this is looking, specifically again in the United States, of all Americans could be uniquely identified by 3 pieces of information: their zip code, their birth date, and their sex. And when I first saw this, I thought, well, that's pretty incredible. How can that be? And then you just basically do some multiplication. It's very clear. There's 42,000 zip codes roughly in the United States. There's 365 different birthdays. We're going to leave out leap days for the moment and just say 365 because it's a slightly lower number. For 80 years average lifespan. And most individuals, not all, but most individuals identify as one of 2 sexes. So you just multiply those numbers together, 42,000 by 365 by 80 by 2, you get 2.5 billion combinations. There's only 330 million people roughly in the United States, which means most people uniquely have one of those combinations of attributes. And there's actually a website where you can test this for yourself, aboutmyinfo.org/identity. You go and give it these 3 pieces of information if you're willing to do that and see whether or not you're individually identifiable. Now, these days, we have new technologies. We have things like differential privacy to try to guarantee our privacy. And what we've seen recently, for example, in the census, the most recent census results in the United States, is the differential privacy does get us some level of anonymity, but it also has other kinds of effects where smaller groups in the data tend to get washed out because of the randomness that's introduced into the data as a result of differential privacy. So these are the things we need to understand. We have need technologies to be able to think about these things, but those technologies give rise to other externalities. And unless we actually audit and study them, we don't know the full impact. Automation is another big one. I'm not going to belabor this too much because this is probably something that many of you have already been thinking about. What is the surge in automation that's going on right now in different areas, especially machine learning and generative AI? What does it mean for jobs? Well, there's many studies that say it's going to eliminate large numbers of jobs, potentially tens of millions of jobs. And so we might take the approach of saying, well, we should just limit the scope of technology. There are real benefits we could get here. There's things like, machine learning systems now can predict cancer for things like breast cancer on par or better than human doctors. So if we can harness that technology, there are real benefits here. At the same time, some people feel they're threatened by things like generative AI, and it might be hard to read this slide, but just as a simple example to show my students who are learning computer science, I asked it to generate some code to generate the first 10 prime numbers. It generated functional code in Python, actually decomposed and commented, which is oftentimes better than I get from my students. Right. So the question is, how do we think about education in this new world? How do we reskill people and retrain people? Because the numbers look pretty stark in terms of the number of jobs that are threatened by automation. Right. Depending on who you talk to, I just gave you a sampling of statistics here. Between 9 and 47% of jobs are threatened by automation by 2030. So less than a decade from now. If we see that train kind of coming down the track, what do we want to do? And we need to put a lot more investment into things like education and reskilling. And we know that now, but those are not necessarily the steps that we actually see public policy taking. So one of the things that behooves us as technologists is not only to think about mitigating the harmful effects of our technology, but helping inform other people in the world to make choices with respect to what is happening in terms of movements in the world of technology and the societal consequence that that will have. We need to have this integration of technologists and policymakers and people who think about what are the value trade-offs involved in these situations to make better decisions to actually get the outcomes we want, rather than just developing more technology and believing that we're going to get good outcomes just because of wishful thinking. We've already seen that that's not going to be the case. The market's not going to give us the solutions we want in all cases. And so I won't talk about this, even more, because there was a lot of, thought going into this now, other than to raise the point that says this is critical and we need to be, thinking more about the interplay between technology and policy here. And I'll finally kind of get into our last big issue, which is thinking about free speech and democracy, the notion that in many places our information space is polluted by things like misinformation. But it's not just people who are trying to influence our opinion through, bad intent. One of the things we do, for example, in our class is we give students a little simulation of a social network, which says, imagine you have two kinds of users, ones who have a slight proclivity for reading, we do it in a political setup. So let's say left-leaning news sources, just slightly, and another group of people, who are the red notes here, who have a slight preference, again, not huge, but a slight preference for right-leaning, political news sources. And what you're trying to do is you're trying to maximize click-through on content. So you're trying to think about what information should get suggested between different groups of people. And everyone is friends in this network. So when this network starts, I'll put some more users in it. Everyone is friends. Everyone is connected. And the color of the connection is an indication of the strength of connection between two people. Darker means a stronger friend connection. And then we say all this network is going to try to do is trying to maximize click-through rate. It's not trying to do anything around misinformation. It's not trying to get people to be in particular groups. It's just maximizing click-through rate, which is what many companies do. So how does this network evolve? And so over time, we show them, here's what happens at day 50 and day 100, 150, 250. When we get up to day 500, the network's basically broken in half. And this isn't a result of trying to say we want to create political polarization or bad people trying to do the wrong thing. It's about trying to optimize particular metrics that people think are reasonable metrics to generate revenue for a business and the externalities that are generated as a result. And unless we actually look at these things and make different decisions about what we are trying to optimize and the results we're trying to achieve, these are the results that we'll get in our society. And so it shouldn't be a surprise that we get polarization. This is a natural consequence, right? This demonstration took me half a day to code up, right? But people didn't look at stuff like this before they created planetary scale networks and thinking in terms of how information is shared among people. And it brings up ultimately this question of what are the value trade-offs, right? In the case of social networks, we think about the trade-offs between free speech and about freedom from deception and what that means for a democracy, and freedom from harassment, what that means from human dignity. But these things are in tension with each other. The more freedom we allow in speech, the more opportunities we create for harassment and for deception. And so we need to be clear about what those things are, rather than just believing that technology is going to solve our problems. And so that's I want to end on a point of optimism. It doesn't have to be this way. Technology is not just a wave that washes over us. We are agents that can think about how to shape the effects of technology, but this is the problem of collective action, right? So sometimes it gets couched in particular terms, say by tech companies, that says, well, you have a choice. If you don't like the impact of Meta or Facebook on democracy, just delete Facebook, right? And the problem there is individual action is insufficient. If I delete Facebook, for me, it does not inoculate me from the effects of Facebook on democracy on the planet, right? In places where there are democracy, or in other governmental forms where there may not be. I don't get inoculated from those effects. So individual action by itself is not enough, right? There are some things you can do as an individual. You can set the privacy settings in your apps or your browsers. You can use incognito mode, or decide to try to keep your search history private. There's all these cookie preferences that get set now thanks to the General Data Protection Regulation. But again, those things by themselves are not enough. What we need are systemic solutions. The way we think about systemic solutions are, for example, when we got cars, when we got on roadways, we didn't even have rules of the road. We got a bunch of accidents. We got a bunch of fatalities. We needed to have some regulation that said, we're not going to stop you from driving cars. That's still your choice. You still have freedom. But we're going to tell people they need to drive on a particular side of the road in particular countries. We're going to put in guardrails. We're going to put in speed bumps around schools. We're going to put in stop signs and stoplights. We're going to put in speed limits. So these are things that guarantee safety for everyone participating in the system, even though you still have personal choice. That's what we need to do with technology, is have more guardrails for things like, say, before you deploy an algorithm, it needs to be audited. If you want to think about collecting information, there needs to be a privacy policy around it, which thinks about how long that data is maintained, what data is collected, what sort of inferences are done on it, and most importantly, giving people rights around deleting that data and knowing how that data is being used about them. Right? These aren't things that are particularly difficult. They're just things that don't exist in many places because we have not actually pushed for them to exist. And as technologists, we have some responsibility for that. Thinking about the responsibility of technologists, we also need to think about how we think of a code of conduct. Now, ACM and IEEE actually have a code of ethics. And I think they're worthwhile, but part of the problem is if I violate them, the real penalty I get is being kicked out of ACM or IEEE, which for most people is actually not that bad of a consequence, right? It's not like medicine where you lose your license and can't practice. We don't stop people from practicing computing or programming because they've had ethical lapses. And that's something we need to think about more seriously. We need to think about checking the power of large technology companies. What are the guardrails we put in place around the data that gets collected and how it gets used? Again, not rocket science here. This is more a matter of will to be able to do it than thinking about how difficult it would actually be to pull off. There's some low-hanging fruit here in terms of things like privacy policy that we need to, and I think there will be some movement in this in the next few years. We've already seen some in the European Union. I think we're going to see more globally. We've seen some in China as well, seen some pockets in the United States, but not anything at a national level. And lastly, when we think about democracies around the world, we need to think about building democracies that are capable of governing technology. How do we get technical expertise into government? That's a responsibility for us as computer scientists. If we only focus on technological problems, we will not be addressing the larger societal problems that our technology is actually creating. And so that's my message to you, is thinking about folks who are involved in the effort of technology, is we have great responsibility because we have great power in this domain, and that responsibility needs to be exercised beyond just the realms of technological development. So with that, I will stop the share and open it up. We have a little bit of time for questions.
Woo, Mayron. If you could see the chat, first of all, we want to thank you for your time. Great presentation. There are lots of comments going back and forth, lots of Q&A, lots of engagement by the attendees. I think we had up to about 150 on at one time. But Susan, I'm going to throw it to you. I think we've been going back and forth behind the scenes to select at least one question, because we have pretty close to the top of the hour approaching.
So, Mayron, I'm kind of melding several comments and questions from our participants in asking you regarding ethics or ethical behavior and social awareness, which seem to be called for in the computer science curriculum in our classrooms. How can we make that happen?
So one of the things we think about doing is we think about, building discussions of ethics and issues of ethics into every computer science class. That's actually something we've done at Stanford. So all of the classes of the required core for our undergraduate majors have an ethics component in them now, in addition to sort of standalone separate classes. And the way we think of this, we think about when I think about the evolution of software engineering, I think about there's been times in the past where, in the early days, people were just hacking code. Then people realized you need to think about quality assurance and testing as a function, and that became a first-class thing. Then people realized you need to think about user interface and user experience, and that became a first-class thing. Then people started thinking about privacy and leaking data, and that became now most reasonable software companies have a privacy team. We think in that same sense, the next level of evolution for software engineering is for software engineers to think about the notion of ethics and value trade-offs in what they build. And that has to be a function in the process of developing software. We have not developed that capability, but that is something that we need to develop for ourselves and help our students develop in the future by not having ethics be a separate thing, but actually having be integrated over and over into what we teach students about software development.
So one last quick question we have, I'm just going to choose one from the Q&A, and this comes up. This person says, I know this is a silly question, but we can't just randomize what we do in the trolley problem. So the question becomes why is this problem only unique, and what are the ethical issues behind it? But why do we need only autonomous vehicles in your example?
So I think part of the question here, and someone just said, ethics is so subjective, who decides what fairness is? I think the big question here is this is a societal question, right? This should not be a question for 3 software engineers sitting inside the company who happen to be programming a module in an autonomous system to make the decision for the rest of society. What we need to have are guardrails in place that say when these consequential decisions get made, there needs to be broader engagement, and that needs to be required for the development of software, right? So that's why we think of these things when we think about value trade-offs. Yeah, different people favor different values, but we have this other technology that exists in many places in the world called democracy, which is how we get a group of people with different opinions to be able to live together without killing each other. Is we have ways of being able to mesh different values together to come up with something that we think is the thing that at this point in time or a given point in time, society actually wants. So if you look at things like privacy policy, there's actually a lot of public push for having more privacy policy. We just need to actually get policymakers to make that decision, and they're getting closer. So I'm optimistic about what's possible.
Well, all right. I think we have reached the top of the hour. Want to thank everyone for attending today. Thank you, Mayron, for a provocative presentation. And we bid you farewell. Until the next time, everyone. Thanks again.
Thank you very much. Take care.